All right, what's up, y'all? We're going to look at example 3, section 5.1. Example 3 deals with the volume of a sphere, and we're going to estimate it using a method like this. We're going to estimate it not using rectangles, but by using cylinders. What? This is crazy. Let's see how we're going to do this. So, let's see. Page 267. Page. Let me see. Is this messed up? Oh, goodness gracious. Here we go. That's a little bit of a better view. Okay. Page 267, example 3. Okay. And we're talking about the volume of a sphere. And we're not going to use, I know the volume of a sphere is what? 4/3 pi r cubed. But we're not allowed to use this. We're not going to use that to find our volume. We're going to use that other method they have there. And the method is somewhat straightforward. Let's consider, well, actually it's not straightforward. It's kind of tedious. I shouldn't lie to you. I usually lie to you, but I guess I'm not going to lie to you today. So let's consider this circle, and let's assume that the circle is like in the middle of the sphere, so it's coming out of the front and goes behind. So here's our sphere. It's going around. The center of the sphere is at the origin of my graph here. Now, let's consider what we're going to do is we're going to take rectangles. We're going to rotate them around the sphere. Okay? So I have this rectangle here. The midpoint is on the sphere itself. And if I rotate it around, if I take this and rotate it around the x-axis, rotate it around that line segment, it's going to kind of look like this. It's going to be a cylinder. Okay, and kind of like that. And it goes, and kind of like, okay. Then back around the front. So if I take this rectangle and I take it around the sphere, it will kind of look like a cylinder. And then I'll add up the volumes of those cylinders. Area of a circle, area of a circle is pi r squared, and I'm going to use this. I'm allowed to use this in my little world here. So volume of a cylinder is going to be height times that. Height times the base for the volume of any of those kinds of shapes. Height times whatever the base is, as long as it's just that high. Anyway, so the volume is that of these cylinders as we go across here. So when looking at the cylinders, the height is the change in x. So you can see the height of this cylinder is from here to here. How much the x changes. That is the height of it. It's kind of on its side. Okay, so that's the height, the change in x. And the radius is going to be that the y value, the height of the graph. I guess it will be here in the middle. That'll be the radius. So for the radius, that will be the y values, y or f of x values, and the height is going to be the change in x. Okay? So what I need to do is come up with an equation for this half circle here, and then I can draw rectangles up to it, and then I'm going to spin them around. Okay, well, how do I find this right here? I can actually use the Pythagorean theorem. Okay, this is 4, that's x, and that's y. We'll use the Pythagorean theorem and then solve it for y, and that will give me an equation for this half circle. So x squared plus y squared is equal to, let's see, 4 squared. Okay, and solve this equation for y. It's going to be 4 squared was a 16. Y squared equals 16 minus x squared. And then take the square root. So y equals the square root of 16 minus x squared. So this is my equation. Okay, so let's look at just that half circle there, and we'll divide it up into some segments and see how it is. For my height, for my change in x, I'm going to use 1 like I did in that other example. 1 is a very easy number to work with. Okay, so let's just consider that half circle, and by finding these rectangles, I will find the radiuses. Okay, so the height is always going to be 1. We're going to find the radiuses. The radii, as they say. I'm going to draw this a little bit bigger so I can more clearly see my rectangles. So that's going to be 4, 4, 4. Okay, 2. To mark 4, you mark it in half and then mark it in half again. So this will be a rectangle. There's the midpoint. And I'm drawing rectangles of width 1 so that the midpoint touches the semicircle. Okay, there's a midpoint. Okay. Let's see. There's a midpoint. Okay, and there's a midpoint. And I'm just noticing here, this is going to be symmetrical on both sides. So I can just do one side and then double it to get the rest. So let me draw these other rectangles here as well, just for, you know, the point of being thorough, I guess. Whoops, that should be in the middle. Fake it. And finally, one here. And if I drew that well, it'll be somewhat symmetric from side to side. It's kind of, but I guess not as good as I'd like it to be. So these are my rectangles. And you can imagine if I cut this out and I spun each of these rectangles around, they would look like this. Okay, they would look just like this. There are 8 cuts here as well. And if I spun each of these rectangles around, you would see these 8 cylinders. And I'm going to add up the volumes of those 8 cylinders. And hopefully it'll be close to the actual volume. Okay, so let's just do this section right here, and we will double it. Okay, so let me see. I'm going to have these 4 cylinders. Now this is at 0.5, 1.5, let me see here, 2.5 and 3.5. I'm going by the midpoints. If I was going by the left or the right, I'd use those values, but I'm going by the midpoints. Okay, now the radius is the y value, so I have to put these values in for x into my function, which is going to be a little tedious, but I've got my handy dandy calculator here that's going to help me out with those calculations. Okay, so let's consider, and the height is always going to be 1, but let's find these the radius values first. Okay, so the x values are at 0.5, 1.5, 2.5, and 3.5. Okay, and what I'm going to do is I'm going to find the y coordinates, or r. Okay, and then I'm going to find the volume. Okay, the volume is height pi r squared. Okay, the r is going to be the y values. The height is going to be 1. I have made the height of each of these 1. Okay, so let's see. Let's use a table. Let's use a table, and I'm actually going to do all of this in the calculator. Whoops. Second plus 712. Let's get this going here. Okay, so for the y coordinates, the square root of 16 minus x squared. Okay, and let's look at, I want to look at a table. I'm going to adjust my table settings. I want it to start at 0.5 and go up by 1. Oh, it was already 1. Okay, so let's look at my table. So you have 0.5, 1.5, 2.5, and 3.5. And these are the y values. You can see beyond that 4.5, I get an error because the graph fails to exist. The domain, I was to find the domain of this function to be between 4 and negative 4. So this makes sense to me. This is what should happen. I should see errors down here. Okay, so I have these are my y coordinates. Okay, I'm not going to actually write them down, but I'll write down the volumes. The volume is the height times pi times r squared. These values are r. Okay, so let's go back to y equals. The height is 1, and I'm just writing that for the sake of writing it. Pi is pi r squared times the value of y1, that's r, y is r, okay, times the value of y1 squared. So times the value of y1 squared. Oh, let me use the other one that looks cooler. There we go. So y2 is going to be these volume numbers. So let's look at the table again. Okay, 49.48, 43. So these numbers I'm actually going to write down. I'll need to add them up. So the volume numbers for 0.5 are 49.48. This is 43.197. This is 30.631 and 11.781. And there might be some slick way to make a calculator add these up, but I don't know it. So I can do it by hand. It doesn't take too long. 49.48 plus 43.197 plus 30.631 plus 11.781. And if I do that, I get 135.089. Now remember, this is just these four rectangles. So if I take this last rectangle and spin it around, the volume of that cylinder is going to be 11.781 in some units. I don't know, imaginary units or whatever. And of course, these ones will be bigger, and there's not much difference between these two. And you can see there's not much difference between the height, so they should be pretty close to each other. But this is just half of the picture here, so we need this other half as well. So let's double this. Okay, take this number times 2. And let's do that by hand. Just kidding. Hit times 2. So 270.178. Okay, and let's see if this is anywhere near the actual value for the volume. So let's say, oh yeah, now I remember that formula. Let's see if we were anywhere close. This is the exciting part, or it'll be the very disappointing part. I don't know. Volume of a sphere is, let's see, 4/3 pi r cubed. Let's put in 4 for r. Our radius was 4. Okay, and let's go ahead and see what this will come out to. So 4/3 pi. Okay, this will not divide by 3 pi. It will divide by 3, then multiply by pi. Okay, that pi is not in the denominator, even though it kind of looks like it there. So 4/3 pi r cubed. So 268.082. Not too shabby. So this was a way of approximating what the volume would be. And of course, if I used more rectangles and more of these crazy cylinders, right? If I had, there's just 8 cylinders here. If I had 1,000,000 cylinders, I would get very close to the actual value, as close as we would need it to be. Of course, we actually know the formula, so let's just use the formula. But I'm just saying, yeah, very close. So that is the end of example 3. Well, actually, in the book, they go through it where they find, use 1,000 slices. And I guess we can look at that while we're here. Okay, that's the actual volume. And you can see, well, I guess I didn't write down enough digits here. Okay, I wrote down this many. But if you use 1,000 slices, you get something really accurate, 0.271, 0.25. So 0.2, let me write down the rest, 25731. So 1,000 slices is accurate to 82, to right there, to as much as I've written before. Okay, and some additional digits here that we don't see. I don't know how close that got there beyond that, but I guess it doesn't matter. It's off right here. So it's accurate to 3 digits, 3 decimals. Anywho, now I'm rambling. So that was example 3, a little bit of insight into that.